This is a review from stuff that you guys have seen in geometry. Okay, we're going to talk about trigonometric ratios. That's our SOHCAHTOA. I know you guys have seen that before. It's our SO is sine is opposite over hypotenuse. Ca is cosine, adjacent over hypotenuse. And TOA is opposite over adjacent, our tangent. Okay, so sine, cosine, and tangent. We're also going to talk about reciprocal functions. What is a reciprocal? The opposite, when you flip it, right? So look, the reciprocal to sine is something called cosecant, CSC. If you notice, instead of opposite over hypotenuse, what does it do? It switches hypotenuse over opposite. Cosine has a reciprocal. It's called secant. You just switch adjacent over our hypotenuse, becomes hypotenuse over adjacent. Tangent and cotangent are pretty much the easiest ones to remember because they look like they go together. You would think that cosine would go with cosecant because they both start with a C, and sine would go with secant because they both start with an S, but that is not true. So make sure that you guys see these reciprocal functions are together. These reciprocal functions are together, and these ones are together. You are going to be expected to know that, guys. You're not going to be given that. So you need to know what the reciprocal functions are of each other and how to find them. Now, we talk about our trig ratios like this, our sine, cosine, tangent, opposite over hypotenuse, that sort of a thing, when we're talking about right triangles. We're doing right triangle trigonometry. So today we're going to focus on just solving right triangles given the triangle. Tomorrow we're going to talk about word problems because you guys are going to have some word problems. We're going to solve some of these problems using a calculator and some of them not. So you just have to make sure that you're paying attention to what the directions are saying. So when you have a triangle, right, a triangle can be drawn several different ways. But what does this little box here in the corner tell me? 90 degrees, right angle. So that means I can use these trig ratios. This right here is called our theta. This is the angle that I'm going to say all the time, like in reference to. Because when you name the opposite and adjacent, it has to be in reference to the theta that they give you. The hypotenuse is always the longest side across from the right angle. It's the longest side across from the right angle. Everybody with me on that? Okay, so when you're talking about opposite and adjacent, okay, what you do is you find your theta in the triangle. I always circle it. The side that is across from it, this would be your opposite. And then the side that is right next to, that's actually touching theta, is your adjacent, like your neighbor, your next door neighbor. Now, sometimes they'll only give us two of the sides, and we have to find the third one. Does anybody remember that formula that you use to find the third side of a right triangle? Yep. A squared plus B squared equals C squared. Your Pythagorean Theorem. C squared is always the hypotenuse. Always. The opposite and the adjacent side, those are the legs. That could be your A and your B. But your C is always your hypotenuse. All right? Do you guys vaguely remember this from geometry? Okay, good. Yeah, that's good. All right, scooting along. All right? It says these symbols we use for ratios are abbreviations for their full names, which we just talked about this. Sine, cosine, tangent, cosecant, secant, cotangent. If you guys look at your calculators, you have a sine button, a cosine button, excuse me, and a tangent button. Above those buttons, do you guys see where it says like sine -1, cosine -1? That is not the same as cosecant, secant, and cotangent. That's something totally different that we'll talk about later. So it's not that you just hit second sine and you get that sine -1. That's not the reciprocal function. That's the inverse. So when we find the reciprocal in the calculator, I'll show you how to do it. It's not that hard, I promise. But again, the first thing you should do when they're asking you to find all 6 trig functions is you should identify a few things. This is what we're going to do in every problem. Identify where your theta is. That makes it really, really easy for you to see which side is the opposite side. Which side is the opposite side here? 3 is the opposite side. And what is the adjacent side? 4. So what is 5? It's the hypotenuse. It's the longest side across from the right angle. I would even go, yeah, sure. I would even go one more step, and I would do this. I would write opposite equals 3, adjacent equals 4, and hypotenuse equals 5. I would write that out so I don't even have to look at the triangle anymore. Because sometimes when you guys are looking back at each triangle and you look, you turn your head, you look, you get yourselves a little confused. And I understand that. So I'm trying to simplify things as much as possible. If you notice in this second triangle, right, here is my theta. So this is still the opposite side. This is still the adjacent side. And this is still the hypotenuse. Do you notice how the signs are the same? This is a ratio. These two triangles are proportionate to each other. Whenever you are asked to find the values of sine, cosine, tangent, or the reciprocal functions, you have to simplify. So you see you have 30 over 50. That reduces to 3 over 5. So just make sure that you guys are simplifying your fractions. Very, very important. All right, so you have a problem like this. It says find all 6 trig ratios. First thing I would do is I would write them down. I would say, okay, well, sine of theta. What's sine? What over what? Opposite over hypotenuse. Okay, so what goes with sine? What's the reciprocal of sine? Cosecant, right? So what would the cosecant be? Hypotenuse over opposite. All right, let's just practice putting our stuff out. So then I have cosine. What's cosine of theta? Adjacent over hypotenuse. What goes with cosine? Secant theta, which would be hypotenuse over adjacent. Good. And then I have tangent of theta. What's tangent? Opposite over adjacent. So what's cotangent? Adjacent over opposite. Okay? Before you even do anything, just write out those trig functions. Write out the ratios so you remember it. So now I'm going to look at my triangle. And I do this, and when I make your answer keys, I will do this because it's easy to make a silly mistake. If you label the sides wrong, then all of your functions are wrong. So take a second just to make sure. Identify the hypotenuse first. What is the longest side across from the right angle? 3, correct? So your hypotenuse is 3. What is 2?
Opposite.
Very good. 2 is my opposite side. And what is your adjacent side? The square root of 5. I would do that right here and then not even look at my triangle again. So you don't make any silly mistakes. So now we go through and this just becomes basic computation. If I want to find the sine, right? Tell me sine is opposite over hypotenuse. What is the opposite side? So your sine of theta is 2 over what's the hypotenuse? 3. Perfect. Can you simplify that? Okay, so it's really easy, guys. Once you find the sine, it's super easy to find the cosecant. Because what do you do with the sine? You flip it. So if the sine is 2 over 3, the cosecant is 3 over 2. Very good. Questions? Anybody? We're okay? All right, cosine is what over what? Adjacent over hypotenuse. So my adjacent side is the square root of 5 and the hypotenuse is 3. So it's the square root of 5 over 3. Can I simplify that at all? Nope. Okay. So if I find the secant of theta, what do I do with square root of 5 over 3? You flip it. 3 over the square root of 5. What is the problem here? Cannot have a square root in the denominator. How do we get rid of that square root? You better remember. We have to rationalize. You always have to rationalize. So think about this. What's the square root of 5 times the square root of 5?
5.
Correct. Because square root of 5 times square root of 5 is the square root of 25, which equals 5. So what you're doing is you're eliminating that square root from the bottom. Now, can I multiply 3 times the square root of 5 and get 15? No. One is inside of a radical and one is outside. So you literally just write 3 and then put the square root of 5. Can I simplify the number 5 in the denominator with the square root of 5 in the numerator? No. Hit in your calculator the square root of 5. Just hit square root 5. Tell me what the answer is. No. What's the decimal? 2.236. So can you say that 2.236 is the same as 5? No, that's why you can't. So the secant of theta is 3 root 5 over 5. You always have to rationalize the denominator. Cannot have a radical in the denominator. All right, so tangent, opposite over adjacent. What's the opposite side? 2 over the square root of 5. So you have tangent of theta is 2 over the square root of 5. Problem? What's the problem? Can't have that. So I just rationalize. So the tangent of theta is, can I multiply 2 and square root of 5 and get something else other than 2 root 5? No. So it's 2 square root of 5. The square root of 5 times the square root of 5 is the square root of 25, which equals 5. So it's just right here. And then you cannot simplify. If there was a 10 on the outside of the root, then yes, you could say 10 divided by 5 because they're both on the outside. So let's go here to cotangent. Cotangent theta is what over what? Adjacent over opposite. So what's the adjacent side? Square root of 5 over. Is that okay? Yeah, that's it. Lengthy process, yes, but nothing you guys can't handle. We're going to go through a whole bunch of examples together. I'm going to go relatively quickly because this is a review, but you're welcome to go back and watch the video and slow it down, rework things. But we're just going to find the exact values of all of these triangles. Some of these are a little different than others, okay? If I look at this first one, do I have any sides that are missing? No. So if I'm going to find all 6 trig functions, the first thing I'm going to do is identify my theta, the angle that I'm using a reference to. What is the hypotenuse? 13. 13 is your hypotenuse. It's the longest side. What is your opposite side? 5 is the opposite. Good. And then what is 12? Adjacent. You can leave it like that if you want. I just think it's easy to go over here and write opposite equals 5. Adjacent equals 12. Hypotenuse equals 13. And then that's just what I'm going to look at. Do I have any square roots? My answer is here. No. So this should be relatively easy for us to do. Find all 6 trig functions. So write them out. The more you guys write this, the more familiar you become with them. So the first one I'm going to write is the sine of theta. Sine is opposite over hypotenuse. What goes with sine? Cosecant, good, which is hypotenuse over opposite. Then I have cosine theta, which is adjacent over hypotenuse. So I have secant theta is hypotenuse over adjacent. Then I have tangent theta, opposite over adjacent. Cotangent theta, adjacent over opposite. You guys with me? All right, let's go through this. We got this. Opposite over hypotenuse, what's my sign? 5 over 13. Good. So what's the cosecant? 13 over 5. Good, Josh. All right, cosine is what over what? 12 over 13. Thank you. So my secant is 13 over 12. Perfect. Tangent. 5 over 12. Good. So what's the cotangent? 12 over 5. Perfect. Questions? Good job, guys. Sure. All right, look at the next one. How's this one a tad bit different? Oh, we're missing a side. Darn it. So let's think about the side that we're missing. We're going to have to find it first. Okay, look at your directions. It says to find the exact values. That means no decimals. That means if you have a square root and it doesn't simplify, nothing's pretty, then you have to leave it as a square root. But how would I find, what side am I missing? I am missing the hypotenuse. That's letter C in our Pythagorean Theorem, correct? So I have 5 squared plus 8 squared equals C squared. So 25 plus 64 equals c squared. 25 plus 64 is 89 equals c squared. And then I have to take the square root. So c equals the square root of 89. Wouldn't my answer really be plus or minus? But how come I don't use the negative value? Good, because you're talking about distance or length. You're talking about the length of something. So this side over here, where my x value is the square root of 89. So we just found the hypotenuse, correct? So here is my theta. Identify theta. In reference to theta, what is 5? Opposite. And what is 8? Adjacent. So I'm going to write opposite equals 5. Adjacent equals 8. And hypotenuse equals the square root of 89. Now you would see if the square root of 89 breaks down. It doesn't, so just leave it. So now we go through and find our trig functions. Sine of theta is opposite over hypotenuse. So cosecant theta is hypotenuse over opposite. Cosine theta is adjacent over hypotenuse. So secant theta is hypotenuse over adjacent. Tangent theta is opposite over adjacent. Cotangent theta is adjacent over opposite. Again, I know you guys know this, but the more we write it, the easier it gets. So now we just fill in opposite over hypotenuse. So 5 over square root 89. Is that okay? Rationalize top and bottom by the square root of 89. So we're left with just 5 square root of 89 over 89. The square root of 89 and the whole number 89 are not the same thing, so you cannot cancel them out. It stays just like that. So we go to cosecant. It's hypotenuse over opposite. Well, my hypotenuse is the square root of 89, and my opposite side is 5. Good to go. Cosine, adjacent over hypotenuse. So 8 over the square root of 89. Is that okay? What do I have to do? Yeah, we have to rationalize. We're going to multiply top and bottom by the square root of 89. So I have 8 root 89 over 89. Can you cancel anything out with 8 on the outside and 89 in the bottom? No. If they did have something in common, you could, but they don't, so just leave it. So then I come on over here, and I have hypotenuse over adjacent. So it's the square root of 89 over 8. And that's it. Tangent, opposite over adjacent, 5 over 8. So cotangent is what? 8 over 5. Perfect. You guys okay? Okay, this one's a tad bit different. I try to make all these examples a little different. I'm missing a side length here, but what am I missing? A leg or the hypotenuse?
A leg.
I'm missing a leg. This is my hypotenuse. Good job, Reese. This is my hypotenuse. So I set up my Pythagorean theorem a little different. It's a squared plus b squared equals c squared, correct? I know one of the legs and I know the hypotenuse. Does it matter where I put 4, A or B?
No.
No, just as long as I don't put it where? For C. So I'm just going to say 4 squared plus b squared equals the square root of 29 squared. What's 4 squared? 16 plus b squared equals. Guys, what is the square root of 29 squared?
29.
Just 29. What happens when you square a square root? It just cancels out, right? So now you just, what's 29 minus 16? So b squared equals 13. So now what? Take the square root. So b equals the square root of 13. Y'all with me? Okay, so this side is the square root of 13. So let's talk about this. It's a little different, right? Here is our theta. So in regards to theta, what is 4? It's the opposite side, good. And what is the square root of 13? Your adjacent. So opposite equals 4. Adjacent equals the square root of 13. And my hypotenuse is the square root of 29. We're going to find all 6 trig functions. So sine theta, opposite over hypotenuse. Cosecant theta, hypotenuse over opposite. Cosine theta, adjacent over hypotenuse. Secant theta, hypotenuse over adjacent. Tangent theta is opposite over adjacent. Cotangent theta, adjacent over opposite. Agreed? Okay. So sine is opposite over hypotenuse. 4 over the square root of 29. What's the problem? Can't have the square root in the bottom. So I have square root of 29, square root of 29. I'm left with 4 root 29 over 29. That's it. So hypotenuse over opposite is the square root of 29 over what? Am I allowed to have a square root in the numerator? Yeah, sure, no problem. All right, cosine, adjacent over hypotenuse. So it's the square root of 13 over the square root of 29. Guys, treat this like it was any other number. What's the problem? You can't have a square root in the bottom. So 29, square root of 29. Guys, when you multiply 2 square roots together, all it is a house times a house makes a bigger house. So you can say the square root of 13 times the square root of 29. If you do that in your calculator, you'll get square root 13 times the square root of 29. And I get a decimal, don't I? All right, but your direction said exact value. So leave it underneath the square root. What is 13 times 29? It's 377. That does not break down. Some of you are like, how do you know it doesn't break down? Well, you can go through your perfect squares. Perfect squares would be 4, 9, 16, 25, 36, 49. Divide that number, 377 divided by 4. If it comes out nice and pretty, you're good. If it's a decimal, just try 9, try 16, try 25. You guys can see if something breaks down pretty easily. But what happens with the bottom here? I just have the whole number, 29. So when you have 2 square roots in the numerator that you multiply together, a house times a house just gives us a bigger house. That's it. So over here I have hypotenuse over adjacent. Same thing's going to happen. Hypotenuse, square root of 29 over the square root of 13. Can I have the square root of 13 on the bottom? No, so we're going to rationalize. What was 29 times 13? So it's the square root of 377. Now this time it's over 13. That's it. Opposite over adjacent. So opposite 4 over the square root of 13. Can I have the square root of 13 on the bottom? Nope. This becomes redundant. You guys are doing a good job. So this becomes 4 square root of 13 over 13. Can I simplify anything on the outside? 4 and 13? No. If it was 12, could I on the bottom? Yeah. But it's not, but always check. So over here, I'm just going to flip it, square root of 13 over 4. We're good? Yep, we're good. The biggest thing you guys are going to have problems with is just remembering to rationalize. You cannot leave a radical in the denominator, so you got to fix it. All right, come on over here. Again, I'm missing a side. What side am I missing? A and a B or the C? An A or a B. Always identify your hypotenuse first. It kind of makes things a little easier. I have my hypotenuse, which is 8, so that means I have to find one of the legs. Doesn't matter. I always write, for whatever reason, because I'm a creature of habit, I always plug in A, and then I find B. I don't know why. That's just what I do. Guys, when you square root, what happens? It cancels. So I have 3 plus B squared equals 64. Minus 3 from both sides, correct? So B squared equals 61. Now what? Take the square root. So B equals the square root of 61. Now, if you're not sure if that breaks down or not, just you guys have your calculators there. Take 61 divided by 4. 61. Why 4? Because it's it's a perfect square. So 61 point something. Okay, so that's not good. So 61 divided by 9. Decimal. 61 divided by 16. Decimal. 61 divided by 25. Decimal. Is this going to break down? Nope, so just leave it. So this is the square root of 61. So identify first your theta. Where is theta? It's right here. So what is the square root of 3? Is that your opposite or your adjacent? Opposite. And then what is the adjacent side? Square root of 61. So write out opposite equals square root of 3. Adjacent equals square root of 61. My hypotenuse equals 8. Whoops. 8. So sine of theta, opposite over hypotenuse. Cosecant theta, hypotenuse over opposite. Cosine theta is adjacent over hypotenuse. Secant theta, hypotenuse over adjacent. Tangent theta, opposite over adjacent. Cotangent theta, adjacent over opposite. You guys with me?
Yeah.
You're doing a great job. So sine is opposite over hypotenuse. The square root of 3 over what? 8. Perfect. When I flip it to find my cosecant, it's 8 over the square root of 3. Problem? The square root of 3. So this becomes 8 square root of 3 over 3. That's it. Cosine, adjacent over hypotenuse, correct? Square root of 61 over 8. That's fine. When I flip it for my secant, 8 over square root of 61. What's the problem? Got to rationalize. God bless you. So it's 8 root 61 over 61. And then our tangent, opposite over adjacent. So square root of 3 over the square root of 61. Problem? Yes, rationalize with the square root of 61. What is 3 times 61? So I have the square root of 183 over 61. Check to see if that breaks down. It doesn't, so we're good. So when I flip here, I have the square root of 61 over the square root of 3. Rationalize. So again, I have the square root of 183, and this time it's over 3. All right, let's move on to our calculator stuff. All right, we're going to use our calculators for this one. It's going to say using your calculator. That means go ahead and pick it up and use it. Now, if I ask you for the sine of an angle, you just hit the word sine, comes up S-I-N, and then you put the angle in, and then you hit enter. Okay? If you want, excuse me, a reciprocal function, remember, cosecant is 1 over sine. So if I wanted the cosecant of, I don't know, 35 degrees, in your calculator, you would have to do 1 and then hit the divided by sign, and then it's sine 35. All right, when you have your reciprocals, you have to do 1 divided by. So if I ask you for the secant of something, it's 1 divided by cosine of that angle. Cotangent, 1 divided by cosine, or tangent. So let's practice. Tangent of 40, round to 4 decimal places. So hit tan 40, enter. What do you guys get? 0.8391. Agreed. 4 decimal places. Cosine 20. 0.9397. Okay. Cotangent 14. How am I going to put that on my calculator? 1 divided by tangent 14. Because it's a reciprocal. So 1 divided by tangent 14. What is it? 4.01.
4.01.
0.07 or 0.8.
0.08, okay. Remember, it's not second tangent where the tan negative 1 comes up. That's not it. Now, cosecant of 80, you're going to hit 1 divided by what? Sine 80. So 1 divided by sine 80, and you get what? Okay, agreed. Agreed. All right. What about the cosine of 52? What'd you get?
0.5877.
I'm glad that came up. Guys, if you're not getting these same answers, don't just sit there and be like, oh, something's wrong. You might be in the wrong mode. You need to be in degree mode. So cosine 52, we get 0.6157. Cotangent, how would I put in cotangent? 1 divided by tangent 78. Good. 1 divided by tangent 78. 0.2123. Yeah?
0.2126.
Why did I say 3? I have no idea. Thank you. There's a 3 at the end of mine. All right, secant. What's secant? 1 over cosine. Good. 1 divided by cosine 34. 1.2062. Okay, good. Guys, what about what's the cosine of 98? Negative 0.1392. Is that okay to get a negative number? Yeah, that's okay. That's totally fine. Totally fine. Anybody have any questions? All right, so that's part 1. You can start your WebAssign tonight. It's due Thursday morning. Tomorrow we're going to finish up using right triangle trig with our word problems. We'll finish that up, but I would get started on your WebAssign so you don't have a ton to do tomorrow night.